Alright, welcome back to my channel. This video is on Domain 1 of the new CompTIA Security Plus Certification Exam, SY0-701. Domain 1 actually focuses on general security concepts, and it has 4 out of the total 28 objectives for this exam. I would like you to pay particular attention to the verbs in each of these objectives. So let's dive in, starting with 1.1. Compare and contrast the various types of security controls. Keywords: compare and contrast. So there are 6 types of controls, which include preventive, deterrent, detective, correcting, compensating, and directive. They can be placed into 4 different levels, which include technical, managerial, operational, and physical. The technical controls use advanced technology to protect systems and information, while managerial controls establish policies and procedures that actually guide and oversee the security operations. Operational controls on their own ensure the day-to-day activities adhere to these established processes. And finally, physical controls do involve the tangible measures to safeguard the company assets and the facilities. But mind you that these categories all work together to create a comprehensive control framework. Now, going back to the different types of controls. The preventive controls are aimed at preventing, obviously, security incidents, while deterrent controls are intended to discourage potential attackers. Detective controls, obviously, are focused on identifying and detecting those security incidents, while corrective controls come in after an incident to mitigate its impact. Also, compensating controls are usually alternative measures to compensate for inadequate primary controls. Finally, directive controls are policies and regulations that provide specific guidance. While it's necessary to learn the definitions of all of these categories and control types individually, it's also important to know that they are not mutually exclusive and to understand how they might fit together. You should also know that it is quite vague and that the majority of the controls can fit in multiple categories anyway, as well as different types. It all depends on the context of the use. Also note that it's different for many organizations because they might decide to combine certain categories or define them slightly differently. So that's about it for objective 1.1. Let's carry on to the next objective, which is 1.2. Objective 1.2. The key is to summarize fundamental security concepts. Let's start with CIA Triad, which is a model for information security that is based on 3 pillars. Confidentiality, which preserves restrictions on access to information, including protecting personal privacy and proprietary information. Integrity, on the other hand, protects the information from being modified, destroyed, or tampered, and ensures its authenticity. Availability does ensure that the information is always accessible and usable in a timely and reliable manner. Together, the CIA Triad is often represented in a triangular pattern because each element actually connects with the others. For instance, implementing multi-factor authentication to protect data confidentiality can also make it harder for employees to access this data. The 3 principles definitely do work in harmony to create a robust shield against cyber threats. But in addition to the CIA Triad, we do have non-repudiation, which upholds the trust and accountability through mechanisms such as authentication, digital signatures, and even audit trails. Moving forward, the AAA framework, which stands for authentication, authorization, and accounting. Authentication identifies a user by verifying their credentials such as username and password, while authorization determines what task that user who has been authenticated is allowed to perform. Accounting tracks how many resources a user consumes and the route. Together, the AAA helps to manage and secure networks by screening and tracking users, as well as enforcing policies and using audits to help prevent unauthorized access. We also need to talk about gap analysis, which simply put, helps you achieve the desired state of security compared to the standard. In order for us to make all of these happen, we focus on using zero trust, which is a principle of never trust but always verify, or rather, never trust and always verify. To implement zero trust though, you need two key components to come together. Control plane, which is the brain of the operation and decides who gets access to what, and the data plane, which is a highway for data. The data plane ensures that only authorized traffic can go through the network. Now, moving on to physical security, which we talked about a little earlier. It is useful to protect the people, the assets, and the infrastructure from threats. Aspects of importance include bollards, which are barriers against vehicles, access control vestibules, which are control spaces for individuals to pass through, fencing, video surveillance, security guards, access badge, lighting, sensors, infrared, pressure, microwave, ultrasonic, you name it. In addition to all of these, the concept of deception and disruption technology is equally vital, with factors like honeypots, which lures attackers so that you can monitor the latest attack methods, or honeynets, which is a network of honeypots, or simple honey file, which is a bait file designed to detect and track unauthorized access attempts discreetly. Honey tokens are also available, which are just fictitious data or credentials placed as a trap to actually detect unauthorized access. That wraps it up for Objective 1.2. The next chapter is 1.3, which is going to explain the importance of change management process and their impact to security. Change is a normal part of life, and businesses are no exception. Companies often need to update systems, adopt new technologies, or restructure their operations. To ensure that these changes go smoothly and do not cause problems, these businesses need to have a well-organized process to manage them. This is what we call change management. A change advisory board is a group of people who oversee and approve these changes. They make sure that the changes are necessary, well-planned, and won't disrupt the business or compromise security. By following a structured change management process, these businesses can then reduce the risk, maintain the security, and improve overall efficiency. So let's break down these processes one by one. The approval process is like getting a green light for a new project. It ensures that the changes are necessary, beneficial, and they are in line with the company's goals. The process usually involves identifying the need for change, proposing the change, reviewing and approval, as well as documentation. Ownership. Ownership in change management means assigning responsibility for a change to a specific individual or a team. For instance, the security team might be responsible for implementing a new firewall. This ensures accountability and helps track the process or progress. Stakeholders. These are the people or groups who are affected by the change or have an interest in its outcome. They could be internal stakeholders like employees, managers, and other departments, or external stakeholders like customers, suppliers, and regulatory bodies. Impact analysis. Before you make this change, it's important to assess its importance, potential impact to the organization, which could be security risk, operational impact, financial impact, and so on. Testing ensures that the change works as intended and does not introduce new problems. It's like test driving a new car before you buy it. A backup plan is a way to undo a change if something goes wrong. Think about a backup plan or plan B. A maintenance window is a specific time period during which system maintenance and updates can be performed with minimal impact to the users. It's often done during off-peak hours or on weekends. An SOP, standard operating procedure, are detailed instructions that outline how to perform specific tasks. They help to ensure everything is consistent, efficient, and in compliance with security standards. By following these principles and processes, organizations can effectively manage the change while maintaining security and minimizing risk. There are technical implications that are like a domino effect, such as one small change that can have a ripple effect throughout the system as we see every day in the news. For instance, allow list or deny list, restricted activities, downtime, service restart, application restart, legacy applications, and other dependencies. Finally, documentation and version control are equally very critical. Documentation identifies the changes made and by whom, such as updating diagrams, updating policies and procedures, while version control tracks these changes to the documents and the projects. That's about it for Objective 1.3. The next is 1.4, which will explain the importance of using appropriate cryptographic solutions. The objective of 1.4 focuses on security concepts related to cryptography. It covers solutions like public key infrastructure, encryption, cryptographic techniques, blockchain technology, and certificate authorities. PKI is a system that uses public and private keys to encrypt and decrypt information. Public keys are like public locks. Anyone can have it, and it is used to encrypt messages and validate digital signatures. Private key is like a personal combination or key. Only the owner should know it, and it is used to decrypt messages and also generate digital signatures which serve as a cryptographic seal of authenticity. Key escrows are trusted third party that help you recover your private key if it gets lost. They use a physical device known as a hardware security module that ensures that the cryptographic keys are securely stored. By using PKI, organizations can actually ensure that the security and integrity of the digital communications. Now, encryption in layman terms is like a secret code. It is a way that you scramble data so that only people with the right key can understand it. Think of it like putting a message in a lockbox and only someone with the right key can open it and read the message. There are multiple types of encryption. A full disk encryption is like locking your entire computer hard drive. Only you can access the data on it. A file encryption is like locking individual files on your computer. Only you can open and read those files. Database encryption is like locking a specific database, protecting sensitive information like credit cards or medical records. Transport encryption is locking a letter before sealing or rather before mailing it. It ensures that the letter can only be read by the intended recipient. But how does encryption work? It could either be symmetrical or asymmetrical. For a symmetrical encryption, the same key is used to encrypt and to decrypt the data. Meanwhile, for asymmetric encryption, two keys are used. We previously talked about the public and private key. The public key is used for encrypting the data, and the private key is used to decrypt it. Why is encryption important? Well, it helps us protect sensitive information and keeps it from hackers and cyber threats. It ensures that we maintain the confidentiality, integrity, and authenticity of the data. Multiple cryptographic techniques can be used in securing our data. Obfuscation is like making a puzzle out of a simple picture. It's a technique that hides the true meaning and purpose of something, often used to protect sensitive information and make it harder for others to understand it. Common obfuscation techniques include Steganography, which is hiding secret messages in larger, seemingly innocent messages. It's like writing a message in an invisible ink on a regular letter. Tokenization replaces sensitive data with unique tokens, like replacing a credit card number with a random code, while data masking disguises the information, which is sensitive, with fake or random information, similar to using a fake name instead of your real name. Hashing is actually creating a unique digital fingerprint of data. It is like summarizing a book with a single word. But to make your hashing algorithm stronger, sorting is used, which adds a random string of characters, for instance to a password, before hashing it, making it a lot harder to crack. Digital signatures verify the authenticity and integrity of the digital document. It's like having a digital signature that proves that the document has not been tampered with. Key stretching, finally, is making it harder for hackers to guess passwords by adding complexity to the hashing process. These techniques are used to protect sensitive information, prevent unauthorized access, and maintain data privacy by making it difficult for others to understand or manipulate the data. Blockchain, in layman terms, actually means, for instance, imagine a digital ledger where all transactions are recorded and they can never be changed. That's blockchain. It's like a chain of blocks, each block containing a set of transactions, and once a block is added to the chain, it's very difficult to change it or remove it. It is very important because it maintains security, because it is decentralized, which means there is no single point of failure and it's much harder to crack. It's also transparent. Everyone can see the transactions on a blockchain, making it trustworthy. It's very efficient because blockchain can automate many processes, making them faster and more efficient. In the real world, cryptocurrencies like Bitcoin and other cryptocurrencies use blockchain to record transactions. Supply chain management also uses this technology to track the journey of products from production to the consumer. In healthcare, medical records are securely and efficiently stored, as well as recording property and ownership transactions in real estate. Finally, certificates and digital trust talk about a digital certificate, which is like a digital ID card. It verifies the identity of a website or an individual. Certificate authorities, or CAs, are organizations that issue these certificates. When you visit a website with a valid certificate, you can trust that the website is who it claims to be. That wraps it up for Objective 1.4 and Domain 1. The next video, stay tuned, we will cover Domain 2, which is threats, vulnerabilities, and mitigations of cybersecurity threats.